The previous lecture, we saw how a plasma can freeze in the magnetic field as it moves, and it can carry as it moves along. And we also see a glimpse of what happens, a glimpse of reconnection and magnetic reconnection, and what happens when the magnetic field lines are being annihilated. So now, if you see this magnetic reconnection, this is the main source in which the plasma gains energy in a solar flare, or in your neutron stars or pulsar polar cap, and why so far. And of course, vicinity, what you see this dancing lights in the northern hemisphere, which is commonly called as the aurora borealis, or more commonly it is referred as a northern lights. So this is even the process by which this aurora borealis happens also involves this magnetic reconnection. So let us have a look at how this magnetic reconnection happens. During a solar flare, a storm of high energy particles are ejected from the solar surface, and now as this plasma, which flows at a supersonic speed, as this plasma approaches the Earth, the magnetic field of the Earth will act as a barrier, and this plasma collides with the magnetic field and create a Bohr shock. Now, at the shock front, the charged particles are accelerated. Well, how a charged particle are accelerated in a shock front, we will see it in our later lectures. For time being, let us accept the fact that shock front can accelerate the charged particles. So the plasma is accelerated at the Bohr shock, and the accelerated plasma flows downstream of the shock along the magnetosheet. Now we saw in the previous lecture, plasma have a quality of freezing the magnetic field. So the plasma in the downstream, it freezes the Earth's magnetic field. As it flows along the magnetosheet, it drips off the magnetic field of the Earth and extends it as a tail on the other side of the Earth, and that tail is called as your magnetotail. Now, if you have a closer look at the magnetotail, you can see the upper portion of the magnetotail and the bottom portion of the magnetotail, the magnetic field sign will be opposite. Then I can always select a plane along the equatorial region, so where the magnetic field line changes above and below. So as I move along above or below, the magnetic field line changes. Therefore, the field along this plane has to be zero. So that is, this plane where the magnetic field is zero is called as your neutral sheet. It is neutral because there is no field. Now let us have a closer look at this neutral sheet. So now, as I told you earlier, as you move above and below the neutral sheet, so the magnetic field is going to change the direction. Therefore, at the neutral sheet, a strong curl of B exists. Now, as well as the plasma keep compressing the field, there will be a variation of the B with respect to time. So you have a del B by del T. So these changes in the field will induce an electric current which flows along the neutral sheet, and so the neutral sheet is also called as your current sheet. Something more interesting happened at the neutral sheet. That is, now as the plasma keeps compressing the magnetic field lines further and further and further, at some point, and the field lines comes closer and closer to the neutral sheet, and at some point, the field lines merge or basically annihilate at the neutral sheet, and annihilate and get restructured. So now, in this process, amount of magnetic field energy density is released, which goes to B squared by 8 pi, and that energy is dumped on the plasma along the neutral sheet. So you have an energetic plasma flowing along the neutral sheet. So this process in which the magnetic field lines are annihilated and then get restructured is called as a magnetic reconnection, and all the magnetic reconnection there will be a loss of the magnetic energy density or energy. So, and that energy is dumped into the particle, and that's how the particle is being accelerated at the magnetic reconnection. So now, if you come back to the situation, what happens around our Earth's magnetotail. So as the solar plasma and it keeps compressing the magnetic field lines, so these lines annihilate, and the plasma gets and the magnetic field gets annihilated along the neutral sheets and the particles will get accelerated, and this high energy particle will be traversed along the magnetic field line of the Earth, and it reaches the northern pole. And now, since at the northern pole the magnetic field density is higher, so the velocity of the the gyrating electrons will be more, and therefore it excites the oxygen atoms in the atmosphere and then emits your green and red lights, and that's what you see as a beautiful aurora borealis or the northern lights. Well, so now, okay, we said nicely, yes, of course, these magnetic field lines are annihilated. It's a nice story where the magnetic field lines are annihilated, and then the energy is dumped into the particle, and the energy particle is ejected out. Now, what are the conditions? This can happen, or is it that always whenever any plasma compressing a field it can create annihilation? Or other way, I can do what should be the plasma pressure it should create such that the magnetic field line should be annihilated. Conversely, what we can see is now as the current is flowing, is there any resistance? If the current flow has some resistance which objects the current flow so that the current stops, then once the current stops, the field line combination also will stop. So, and that can actually stop your further recombination of the magnetic field lines. Now we can see what stops the flow of the plasma is the collisions. Now, as the collisions increase, if the collision rate or collision frequency is higher, so then the current flow can be stopped and the reconnection can be halted. So now, what decides the collision frequency? The very obvious answer is, of course, the density of the plasma, and another one important thing is the velocity of the plasma. So these two decide the collision frequency. In the next lecture, let us have a careful derivation of what are the factors in which this collision frequency is depending upon, and what are the conditions under which the magnetic reconnection can happen and the plasma or the charged particle can gain energy in the neutral sheets. Thank you.